Have you ever driven an electric car and felt that strange, smooth slowing down the moment you lift your foot off the accelerator? It almost feels like the car is reading your mind. And here's the crazy part. While slowing down, the car is actually charging itself. Today we're breaking down exactly how that happens. This is regenerative braking, one of the most misunderstood but most brilliant features of electric vehicles. And by the end of this video, you'll understand how it works, why EV brake pads last insanely long, how much range you can actually recover, and why this technology matters far beyond electric cars. Let's jump in. To understand regenerative braking, we first need to understand a problem every gasoline vehicle has: wasted energy. When you press the brake pedal in a normal car, the brake pads squeeze the brake rotor. The car slows down because of friction, and that friction turns kinetic energy into heat. Think about that for a second. Your car uses fuel to create motion, and then every time you slow down, it throws that energy away as heat. It's an incredibly inefficient system. Electric vehicles change that. They don't just throw away energy, they recycle it. Here's the key idea. An electric motor doesn't just move the car. Under certain conditions, it becomes a generator. This is the same physics behind wind turbines or hydroelectric dams. When something rotates a coil inside a magnetic field, electricity is produced. In an EV, when you press the accelerator, electricity flows from the battery, the motor spins. When you lift the accelerator, the wheels spin the motor generates electricity, the battery gets charged. It's the same device, doing the opposite job. Simple concept, brilliant execution. And this opposite job is what slows the car down. Instead of friction, the car resists the motion by generating electricity. You get both braking and charging at the same time. If you've ever driven a Tesla, a BYD, a Hyundai Ioniq, or any modern EV, you've probably felt this before. You lift your foot from the pedal, and the car slows down smoothly, almost like invisible hands are holding it. That sensation is regenerative braking at work. Some cars let you adjust how strong it is. Strong regen. You barely touch the brake pedal. This is one-pedal driving. Medium regen. Feels like an engine brake in a diesel vehicle. Low regen. Feels similar to a normal gasoline car. But in every case, part of your slowing down energy goes back into the battery. This is the question everyone asks. How much range does regenerative braking really give you? There's no single number because it depends on your driving. City driving with lots of stop and go? You can recover 10 to 20% of your range. Highway driving with very few stops? Maybe only 1 to 3%. Real-world examples. In cities, taxis using regen significantly extend brake pad life and reduce energy usage. Tesla owners often see 5 to 10% of their total consumption coming from regen on everyday routes. In heavy traffic, I've personally seen regen recapture over 25% of the energy. On steep downhill drives. So yes, regenerative braking doesn't give you free energy, but it reduces waste massively, which means more range and lower consumption. Because regenerative braking handles most of the slowdown, physical brake pads are used far less. In a gasoline car, brake pads often last 30,000 to 50,000 kilometers. In an EV, some owners report 100,000, 150,000, even 200,000 kilometers on their original brake pads. Why? Because in daily driving, the car is slowing down electrically, not mechanically. Brake pads only come into play in emergency braking. At very low speeds, regen becomes less effective. When the battery is 100% full, nowhere to store regen energy, this means less maintenance, lower cost, safer, more predictable braking. Here's something surprising. Regenerative braking is not new. Electric trains have used it for decades. Some industrial elevators use it. Even Formula One hybrid systems use a form of regenerative braking called KERS. But EVS brought it to everyday life. and it's becoming so efficient that some companies are developing all-electric braking systems. No hydraulic fluid, no calipers, just motors and software. We're not there yet, but we're getting close. So the next time someone asks, "Do electric cars charge while you drive?" you can say, "Not exactly, but they do charge while slowing down." And that simple idea, recycling energy instead of wasting it, is a huge part of why electric vehicles are so efficient. If you'd like more simple EV science, consider subscribing and let me know in the comments. What should we explain next?